All right. Hey guys. So today, it's no new notes or anything or new information. Um, I'm just doing the videos to sort of help walk you through some of the problems from the homework, to get you started and to maybe point out a few things that are typical trip up areas for people. Okay. So, excuse me. Um, so the first day, this first day, we've got I'm going to have you guys do 1 through 10 on the 9-2 practice problems on the front. Okay. Uh, so the ones on the front, you do not have to balance. If you do them correctly, meaning get the correct formulas and everything, they will already be balanced without putting any coefficients in front of them. Okay. Now, if you look at it and it's not balanced and you can tell, that means you did something wrong. Okay. So, uh, okay, a few just sort of um, off the like off the top of my head information. So this is I'm just going to head this 9-2 practice problems. Okay, when writing formula equations from words, one thing that's really important uh, is don't forget your Hofbrinkel. Okay, remember when they're alone, the 7 elements that are found as diatomics are H, Hofbrinkel, H, O, F, fluorine. So hydrogen, oxygen, fluorine. Br, bromine. I, iodine. N, nitrogen. And Cl, chlorine. Those 7, when they're alone, you're going to write them down as diatomics. Okay. A few other things for the front half. Number one, they don't tell you this. I think I have it in the notes, or maybe not. I don't remember. Anyway, ammonia. You got to be careful. Ammonia versus ammonium. Okay, ammonia is NH3. Okay, ammonia is NH3. Ammonium is the positive polyatomic off of here, NH4 plus 1. So it's ammonium chloride. So you'd use that to make the equation for it. Okay, a few other things. Let's see. The term, like when it says when heated or whatever, or exposed to light, like number 10, those don't mean anything and they're not part of the equation. That's like the trigger for the reaction, but it's not, you don't represent that in the actual equation, the formula equation anywhere. So you can literally just ignore if it says like when heated or exposed to light or anything like that for what we're doing. Okay, now another thing is in here, if they have something in parentheses, that's the formula for that substance. So like number 4, acetaldehyde, I don't expect you to know how to make that formula. It's in parentheses right here. You don't have to make it, you just write it down. Okay, so if you're looking on here and you're like, well, I don't know what azomethane is. They give it to you. It's right here. Okay, you only have to make the ones that they don't give you. All right, so I'm gonna do one, and so I'm gonna pick one that's got a bit of stuff to it here. Also when it says like at 297 degrees Celsius, like that doesn't matter either. The degrees Celsius, like that's stuff that doesn't matter, the degrees Celsius or whatever. Okay. All right. I'm going to do that one. They've already done this stuff for you. Let's do number 9, I guess, or actually, we're going to do number 10. Okay. I'm going to do number 10 with you. I'm just going to put it under here like this. All right. Manganese 2 iodide decomposes when exposed to light. Okay. So manganese 2 iodide. All right. So manganese is Mn. If we were to look it up on the periodic table, we don't know the charge. That's what the Roman numeral 2 is. That tells us the charge, plus 2. Okay, iodide, IDE ending tells us from the periodic table the iodine. Iodine, we look up here. Iodine is a -1. Okay, move this up a little bit. Look to see if we can reduce anything. We can't. We cross down. So we get MnI2. Okay, manganese 2 iodide decomposes when exposed to light. Decomposes, that's one of our key words. That tells us that the reaction is occurring. Okay, so decomposes tells us we're going to put the yield, the arrow. The reaction is occurring, so decomposes. Decomposes to form, same thing, to form, that's again still part of the arrow, to form manganese and iodine. Okay, so manganese is Mn, okay, and iodine. So and is going to be plus. Okay, now notice, on this manganese, we don't do the charges or anything. We only use the charges when we're making the formula. We're not going to put the charges on the individual elements because they're not ions. They're just atoms. Okay, so we've got Mn plus iodine. Now, remember, iodine, when alone, is one of Hofbrinkel. So it's diatomic, so when it's alone, we've got to put the subscript 2, like that. Okay. So the 2 over here did not come because it's part of Hofbrinkel. The 2 over here came from the charges being crossed down. Okay, if this was, say, for example, if it was aluminum iodide, then you would end up with Ali3. Okay, so this 2 comes from the charges crossing down. When it's alone, if it's one of the 7 Hofbrinkels, then the 2 comes from being a diatomic. Okay, so this is your whole answer. And you can look, it's already balanced, which is, it should be if we're on the front ones here. Okay. All right. I'm not going to do any others. There's only 10 of them on there, so you should be able to figure the other ones out. But as usual, if you guys have questions or anything, message me, text me, and so I can walk through it and help you. Right? That's it.